Hello beta, good afternoon everyone. Let us go ahead and take question number 11 and 12 today of ISI MSQE 2004 paper. Look into the question. This question says you're given this series and you need to tell whether this is convergent or divergent series. Right beta. Now in order to solve such questions, what you can go ahead and do now, you need to see the form of this series. So this is 1 into 1 by 2 plus 1 by 2 into 1 by 3 plus 1 by 3 into 1 by 4 and so on, and it is going till infinity. So just by looking into the form, it should be easily understood that this is of the form 1 upon n into 1 upon n plus 1. See here, this is n plus 1, n plus 1, n plus 1 and so on and so forth. So therefore, what we can go ahead and what we can do is we can take this as sum of the series 1 upon n into n plus 1, and we can say that n goes from 1 to infinity. N goes from 1 to infinity. Okay. Now, whenever you will see this kind of series, there is a trick to solve this thing. So what we will do now, we will say this is 1 into n plus 1 is equal to a upon n plus b upon n plus 1, right? So this will be a into n plus 1 plus b into n upon n into n plus 1, right? So this is going to be a into n plus a plus b into n upon n plus 1. So this is going to be a plus b into n plus a upon n plus 1. And this needs to be compared with 1 upon n plus 1. So I can write this as 0 into n plus 1 equal to this. So now you can just go ahead and compare the coefficients. So a plus b will be 0 and a will be 1. So from here I will get a will be equal to 1 and a plus b will be equal to 0. So 1 plus b will be 0. So b will be minus 1. So therefore, this entire series that I have written, this can now be rewritten. This can be rewritten as 1 upon n minus 1 upon n plus 1. 1 upon n minus 1 upon n plus 1. So this is getting summed. Note that this is getting summed from 1 to infinity. So it means that here I will be summing from 1 to infinity. Here I will be summing from 1 to infinity. So if I start putting down the values, I will get 1 upon 1 minus 1 upon 1 plus 1 is 2. Then I will put 2, 1 upon 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 and so on. So you will see that all these terms will start to cancel out each other. And what you will be left up with is first term and the last term. And now we need to understand what happens when n approaches infinity. So when I will just go ahead and plug n as infinity, I will go ahead and get this as 1 minus 0. That means 1. So we can say that this converges and it converges to 1. But this is in none of the options. So the answer to this question will be D. Okay, beta. Come to the next question. All right. Look into question number 12 of this question, of this paper. So question number 12 says that you are given a function and the function is x to the power t minus 1 upon x to the power t plus 1. And you need to check what happens to the limit of the function, but here t tends to infinity. So we are not talking about limit of the function as x tends to anything. Rather, we are talking about limit of the function as t tends to infinity. So t, notice, is coming here in the denominator, in the power. Now, just try to understand that if I were to go ahead and I were to simply put infinity here and infinity here, then anything to the power infinity can be infinite depending on what x is. Here x is given to me a positive number. So it will be of the form infinity by infinity. One of the case can be this. But x can also be a fraction, right? So if x is say half, then half to the power infinity, this will be 1 by 2 to the power infinity. And 1 by infinity, this will be 0. Are you getting it? So basically, either I will be getting 0 by 0 form, or I will be getting infinity by infinity form. I will be getting some form which is not defined. So because I will be getting some form which is not defined, what I will be doing is I will be using L'Hopital's rule. So if I go ahead and I use the L'Hopital's rule, this will give me, so the differentiation of a to the power x is, with respect to x, is a to the power x ln a. So here I need to differentiate with respect to t. So x to the power t ln t upon x to the power t ln t. Differentiation of this will be 0. This also 0. Limit t tends to infinity. This and this will cancel out and I will get the answer as 1. So definitely it converges, and it converges to 1. Right? So limit exists and it exists at 1. So this is incorrect. Exist, exist, exist. Now we need to check the continuity, right? We need to check the continuity of the function. So in order to check the continuity of the function, I am going to go ahead and check the continuity at, because here I am given the value of x being positive. So what I can go ahead and I can do therefore is I can check what happens to x, right? As x takes values less than 1, equal to 1, or greater than 1, right? So I understand that as t tends to infinity, I realize that this goes towards 1. So whatever my function is, as my t goes towards infinity, so if I'm taking t here, as t goes towards infinity, my function goes towards 1. It approaches 1, right? It goes towards 1 as t goes towards infinity, right? So it can be like this also, function going towards 1, right? So it approaches 1. Now, what I need to do is I need to go ahead and I need to check what happens as I take different values of x, right? So what I can go ahead and do therefore is, let's say that I take the first interval. It has been given to me that x is positive. So I take the interval where x is between 0 to 1, right? So for example, let's say that I have taken x to be between 0 and 1. Say I have taken x to be half, right? So just try to understand that if I will go ahead and I will approach t towards infinity only, and the value of x will be half. X will be between 0 to 1. So I will go ahead and I will get half to the power infinity minus 1 upon half to the power infinity plus 1. So this will be 1 by 2 to the power infinity minus 1 upon 1 by 2 to the power infinity plus 1. Anything to the power infinity, if it is a number, 2 to the power infinity, it means 2 into 2 into 2 into 2 multiple times, infinite times, very, very large number. 1 by very large number will be approximately 0. So 0 plus 1. So this will be approaching minus 1. So for all values of x such that x is between 0 and 1, we realize that this is going to go ahead and approach minus 1. What about x exactly 1? So if x is say 1, then limit t tends to infinity, 1 to the power infinity minus 1, 1 to the power infinity plus 1. So 1 into 1 into 1 into 1 multiple times just gives me 1, and this gives me this. So this goes towards 0. So here only we have seen that, every time t is going towards infinity only, t is approaching infinity. But based on the value of x, I am ending up getting different values of the, where it will approach. Whether it will approach minus 1, or it will approach 0, or it will approach 1. That changes. Now, suppose I take x to be greater than 1. Suppose I take x to be greater than 1. So say I take x to be, say I take x to be 2, right? So I will get 2 to the power infinity minus 1 upon 2 to the power infinity plus 1, right? And here, because I won't be able to solve this, this will be infinity minus 1 upon infinity plus 1, and this will be infinity by infinity form. So this is where I will be going ahead and I will be using L'Hopital. I will be using L'Hopital. So if I just put t here back, and I tend to use the L'Hopital, I will go ahead and get 2 to the power t ln 2 upon 2 to the power t ln 2, and then this will just approach 1, right? So we need to see that although, yes, we see that we get some value of the limit, but we see that the values of the limit changes as x changes, not as t changes. T is approaching t is approaching infinity only. T approaches infinity, but the value that we get keeps changing as the value of x changes. It depends on the value of x. It depends whether x is between 0 and 1, 1 and 0, 0 and 1, exactly 1, or greater than 1. Am I clear with this part? Right? So therefore, we get different values of the limit. The left-hand limit and the right-hand limit will be also different depending on the value of the x that we have in this case, right? So what we can go ahead and do is, now we have the same function and we are trying to approach t towards infinity, but when my x is between 0 and 1, I am getting different value. At x equal to 1, I am getting the value as 0. Here, the value of the function is -1. And after 1, the value of the function is +1. So definitely at 1, the function becomes discontinuous in nature as far as x is concerned. I get different values of the function at for any value less than 1, for any value greater than 1, and equal to 1 as t approaches infinity, and therefore this function will be discontinuous, right? So we can go ahead and say that the limit definitely exists, but it is definitely discontinuous at 1, right? Okay, beta. Thank you.